Hello everyone and welcome to the third video on GooseV2. This video is about the tailwheel unit and how it's built. Let's take a look at the design in Rhino. This is the Rhino design for the tailwheel unit. I gave the parts all the parts a different color, so it's clearly visible what they are and what their function is. They're all 3D printed. These are all the 3D printed landing gear parts bundled together to a single print. The tailwheel parts and the parts for the folding arms on the main landing gear. When I was building the tailwheel, I found out I made a little mistake. Somehow when I was moving stuff around to sort it like this, I accidentally mirrored this part. So this horn is now on this side of the cylinder and it should be like that. So for my prototype I fixed it by making some adjustment to the push rods, but for the finalized design I will adjust the print file. I had my parts printed by a company called Shapeways. It's an online print service. They have a very nice website where you can make an account and upload your 3D models. I uploaded my STL file, then it goes through some checks. When it's okay, you can select the material you wanted and have it printed, and it gets delivered by a mailman to your doorstep a few days later. This is my Shapewear Shop Flying Dutchman plans. You see a nice rendering of the previous project, the 1/10 scale Dornier DO24. In my shop now there only are the parts, the 3D printed parts for the Dornier, but when the Goose is ready, the Goose parts will be here as well. So if you do not have access to a 3D printer yourself, you can order them online. They offer worldwide shipping, so everyone can build the GooseV2 with a nice 3D printed tailwheel. This is the tailwheel unit important in Fusion 360, so I can use motion studies to see how it works. This is it. So now you've seen it on a computer screen, let's check it in real life. This is the built tailwheel unit. Let's check how it works. So this is what I was talking about when we had a look at the design in Rhino. The horn where the linkage stopper is attached to is on the wrong side of the part. It should be on this side, so it's in front of the hole where the push rod goes to. So for now it's okay, I fixed it by making a bend in the push rod, but for the final version I will change it in the 3D print files. Made some improvements to the tailwheel design. The part where the servo is mounted on was flexing a bit, so maybe it's a good idea to make it a bit stronger. So I came up with this, where the servo is in a slot and the part is much wider, so there probably will be less flex. Also on my tailwheel these parts were printed as a single part, and for now maybe it's better to have them as two separate parts. So if you want to have a castering tailwheel, the builder can do it, and if he doesn't want to do it, you can fix it with a screw. So these are the updated parts, and I bundled them together to form a single print.